Hi everyone, welcome back to Constant Learners. In today's video, we'll be covering natural joins in relational algebra. Along the way, we'll review the different types of inner joins so you'll understand exactly where the natural joins fit in. Before diving into natural joins, let's first understand what a join is. A join allows us to combine two or more tables based on a condition to receive meaningful results. This process starts with a Cartesian product which pairs every tuple from one table with every tuple from another. However, this produces a lot of unnecessary rows or tuples. We've discussed this while studying the Cartesian product. So we apply a condition to select only the required rows. But in case of Cartesian product that we studied earlier, all the tuples from one table associated with all the tuples from another table. That is not what happens in join. A join operation combines tuples from different relations if and only if the join condition is satisfied. Now, natural joins fall under the category of inner joins. We are studying natural joins, but to understand natural joins, we need to understand what are inner joins. So, let's quickly go over the three types of inner joins. First is theta join, then we have the equijoin, and then we have the natural join, which is our main topic. But how is inner join different? In an inner join, only the tuples that meet the condition are included in the result. That means it does not include the unnecessary tuples. That means the rows that don't match between the tables are discarded. Now the first type of inner join is theta join, which is represented by this symbol, that is the join symbol along with theta. Here theta represents the condition using only and only comparison operators like is equal to, not equal to, less than equal to, greater than or greater than equal to. So the condition on which we join the two tables can only contain these comparison operators. We'll understand this in a bit. Now, since inner joins only use comparison operators, that is why we say that any rows that don't match between the tables are discarded. Because here we are comparing only, right? And wherever the comparison does not work, the rows don't match, those rows are discarded from the output. Now, since the join relies on a specified condition, it's called as conditional join. We first perform Cartesian product and then select rows that satisfy the given condition. And the output has all the attributes, that is, all the columns are included in the output that are present in both the tables. Let's look at an example for theta join. Let's say we have two tables here, the customers table and the loan details table, right? We need to evaluate which customer is capable for which type of loan. That is, which customer is eligible for which type of loan. Now, in the customers table, we have the columns name, phone number, date of birth, professions, and salary. Now, this column, the salary column, is the most important column in this case. And in the loan details table, we have the loan type, minimum salary, and interest rate. And for this problem here, min salary is the most important column in the loan details table. Now, to evaluate whether a customer is eligible for a type of loan or not, the customer's salary must be greater than or equal to the minimum salary required to avail that kind of loan. Alright, this can be done using Cartesian product and select operation as we have discussed in the previous videos, but today we are not going to perform all of those multiple operations. Instead, we are just going to use the theta join operation. So how are we going to write the query? We start with customers table joining with the loan details table. Now the join condition is that the customer's salary must be greater than or equal to the minimum salary required for that particular kind of loan. So in place of theta, the condition will be customers dot salary, that is the customer's table salary is greater than or equal to loan details dot min salary. So this salary must be greater than or equal to this salary. Now Bob's salary is 80,000, right? Which is greater than 50,000, 40,000 and 30,000. And thus he is qualified to avail all of these three different types of loans. If we talk about Alice, her salary is 48,000. So she cannot avail home loan, which is 50,000, but she can avail the car loan, which is 40,000, and personal loan, which is 30,000, right? So due to her lower salary, she cannot take the home loan, but she is eligible to take car loan and personal loan. And for Carol, her salary is 38,000, so she cannot avail home loan, which is 50,000, car loan, which is 40,000, but she is eligible for personal loan because the min salary required for personal loan is 30,000 and Carol's salary is greater than that. So the output will have Bob, who can avail home loan, car loan and personal loan, Alice, who can avail car loan and personal loan, and Carol, who can avail only the personal loan according to their salaries. Alright, I hope that theta join was clear. Next up is an equijoin. Equijoin is also denoted with the same symbol as theta join, that is join with a theta. But it is a special case of the theta join because the condition in this case is restricted to equality only. That is, the only conditional operator used in the predicate, that is theta, is equal to. Alright, so we can say that equijoin is a part of theta join, of course, because theta join includes the equal to conditional operator also. But whenever we use equal to in theta join, it will automatically be called as an equijoin. Alright, here also we perform the Cartesian product first and then we select the rows that satisfy the given condition, and the output table has all the attributes or columns that are present in both the tables. Let's discuss an example of equijoin. Here we have two tables, the students table and the professors table. We need to join both of these tables where both the student and the professor belong to the same department. Alright, that is, the department of the students and the professors is to be same. So the table will be joined only for the rows where the course for the student is same as the department for the professor's table. Alright, so we start writing the query starting with joining the two tables, that is students join professor's table. And the join condition is to be written in place of theta, where the condition is students dot course is equal to professors dot department. Right, so this is an equijoin because here we are only using one operator, which is equal to. So in this case, Mark is studying IT and thus he will be joined with Dr. Smith, who is also from IT. Rita from CS will be joined with Dr. Allen from CS. Sam from EE will be joined with Dr. Khan from EE. John from IT will be joined with Dr. Smith from IT. And Fatima from CS will be joined with Dr. Allen from CS. Alright, because their departments, or we can say the courses, are same. So this is the output where the student's course is equal to the professor's department. Only those rows will be included in the output. But the output table will have all the columns that are present in both the tables. Alright, so that was equijoin based on simple equality condition between two related columns. Next up is our main topic, which is the natural join. Equijoin was a special case of theta join. Similarly, natural join is a special case of equijoin. Alright, so equijoin was a part of theta join, but natural join is a part of equijoin. That is, whenever there is a condition where we have to check the equality, but a special type of equality, then we use the natural join. Alright, so natural join is a special case of equijoin. Now, in natural join, it can only be performed if two tables have at least one common attribute, and those attributes must have same name and domain, that is the data type. So, both the tables should have at least one same column, one common column. That is, the name of the column should be the same and the data type of those columns must also be the same. Only then the natural join can be performed. Natural join is denoted by this symbol here, that is the join symbol, along with an asterisk mark. The condition is based on equality since it is a special case of equijoin. But you don't need to specify the condition or the attributes explicitly or separately. That means we don't need to write any condition in place of theta. It is understood. The natural join automatically detects the common attributes and eliminates the redundant columns in the output. So until now in theta join and equijoin, what was happening? All the columns were being included in the output, right? But in case of natural join, the redundant columns are eliminated and no condition is supposed to be specified. Whenever a natural join operation is used, the computer or the query automatically identifies the common or the same columns are to be identified in both the tables. Same columns means with same name and same data type. And the columns having equal data or the same data has to be included into the output. Now the first two steps are same as before. That is, it involves a Cartesian product followed by a selection operation which is based on equality of common attributes. If the common attributes are equal, only then they will be included in the output. An additional step in case of natural join is projection, which is used to remove redundant attributes. Right? Let's take an example of natural join. You'll understand it far better. Here we have two tables, the students table and the professors table. In a natural join, we automatically join two tables based on columns with the same name and domain, that is data type. Now in both of these tables, we have a column with the same name, that is department and department. And the data type or the domain is also same, that is character. Here also we have only the characters and here also we are only using characters, right? So data type and name both are same, right? Now, a natural join will automatically match rows where the department column is same in both the tables. That means Mark IT will be joined with Dr. Smith IT. John IT will be joined with Dr. Smith IT. Then we have Rita CS and Fatima CS who will be joined with Dr. Allen CS. And Sam EE will be joined with Dr. Khan EE. So it is understandable wherever the columns have same data, only then, that is equal data, only then they'll be included in the output. So how do we write the query? We write students, natural join with professors. Since it is a natural join, the system automatically uses the common column, which is department in this case, and matches the rows from both the tables based on this column. Alright, we do not need to separately or explicitly state the join condition, that is department, that is students.department is equal to professors.department. That is not required. Alright. Also, unlike an equijoin, the natural join removes one of the duplicate columns. That is, we don't need to include this departments table two times. That's not required because it's the same only. And it is understandable that both of these students, that is Mark and Dr. Smith, are from the same department. Rita and Dr. Allen are from the same department. It is understandable in case of natural join. Alright. So here Mark is joined with Dr. Smith because they're both from IT. Rita is joined with Dr. Allen because both are from CS. Sam and Dr. Khan are from EE. John and Dr. Smith are from IT. Fatima and Dr. Allen are from CS. Alright. I hope this video helped you understand natural joins and the differences between various types of inner joins. I think this could be the most simplest explanation that I could give you for understanding natural join. It is important that you understand what is theta join and equijoin to understand the natural join. If you found this helpful, don't forget to like, share and subscribe for more content on database management systems. See you in the next video. Thank you so much for watching.